Hello everyone, welcome to Gangs of PCM. This is Priyanshu, and together we are going to solve all your physics related worries. Today again, we have come back with a question from JEE Mains January attempt of 2020. This question is from chapter rotation. The concept we are going to use over here to solve this question is called parallel axis theorem. What does the parallel axis theorem means? Parallel axis theorem says that if we have a body, if we have any random body and we want to find out moment of inertia of this body about any given axis. Let's say this axis, this green axis, I, and the moment of inertia about this axis is I. Then how we can find out the moment of inertia about this axis? To do that, we need to know moment of inertia about an axis which is passing through center of mass of this body, and is parallel to the given axis about which we have to find the moment of inertia. Let's say the distance between them is d, and this axis which is passing through center of mass, moment of inertia about this is assumed to be ICM. Okay. Now, what does parallel axis theorem says? Parallel axis theorem says that the moment of inertia about this axis will be equal to sum of moment of inertia about an axis passing through the center of mass and parallel to the given axis plus product of mass of the body, let's say mass is m, mass of the body and the square of distance between the given axes. This is the formula for parallel axis theorem. Now, parallel axis theorem is only valid for rigid bodies. What are rigid bodies? Rigid body or any body is said to be a rigid body if distance between any two points of the body remains constant throughout the motion. Okay, so distance between A and B is not changing, this distance is not changing, then we'll say this body is a rigid body. Okay, so all these formulas are only valid for rigid bodies. Now, what do we have in our question? Our question says that we have to find radius of gyration of a uniform rod of length L about an axis passing through the point L by 4 away from the center of the rod and perpendicular to it. Okay, so let's first draw our rod. Let's say this is our rod, uniform rod. What is the meaning of the uniform rod? That the mass is uniformly distributed across its length. So we can say mass per unit length or lambda is equals to m by L. This is also known as linear mass density. Okay, now we need an axis which is L by 4 away from the center of the rod. So center of the rod is where? The center of rod is at the center of the rod. Yes, okay, correct. So this is L by 2 distance from the our one of the ends or both of the ends. Now we have to find moment of inertia about an axis which is at distance L by 4 from your center. So this is distance. You have to find I about this. Your rod is rotating about this axis. Okay. To solve this, we'll take the help of parallel axis theorem. What does parallel axis theorem says? Moment of inertia about any given axis is equal to the sum of moment of inertia about center of mass plus mass into perpendicular square of perpendicular distance between them. So we have to first find the axis which is parallel to the given axis and passing through your center of mass. So let's say this is your axis. The center is the center of mass for the rod. So this would become your ICM. Okay. Now for rod, you know that ICM or moment of inertia of the rod about an axis, passing through its center and perpendicular to its length is given by what? ICM is equals to ml square by 12. So this is your ICM. Okay. So What you can say about I? So I will become equal to ICM plus mass into what is D over here? L by 4 whole square. I would be equal to ICM, which is equals to ml square by 12 plus you have ml square by 16. Let's take LCM from here. So you'll have m by 4 common, ml square by 4 common. You'll have 1 by 3 over here plus 1 by 4, which would give you what? 4 plus 3, 7. 7 divided by 12. 12 into 4 is 7 ml square. 12 into 4 is 48. Okay, so this is your I. Your I is 7 ml square by 48. Now this is your moment of inertia, not radius of gyration. You have to find radius of gyration now. Okay, radius of gyration represented by k. K is given as root of I by m. Okay, root of I by m. So k is equals to I is already given 1 by m into I. I is 7 ml square by 48. M and m will get cancelled. This implies that we'll have k as root of 7 by 48 into L. This is your radius of gyration, and this would be your answer for the problem. If we look at the options, you can see from here that the first option is the correct option, or option A is your answer. Okay, I hope that you were able to learn something from this lecture. Okay, we'll meet next time with similar type of questions, with similar type of concepts. Till then, bye bye, take care, thank you.